Now let's look at the time period leading up to 0Z. We'll start with the IR imagery in the lower left panel. This is the convection we had been following, and as we move forward in time, notice that that convection decays as we see a trend of warming brightness temperatures. As that occurs, you can see the leading edge of the outflow boundary is no longer obscured by the anvil like it was earlier. So we're able to see the dust behind the outflow boundary. I'll stop this at a later time where we can clearly see that. Here's our leading edge of the outflow boundary, and it is pink behind that, indicating dust in the dust RGB, and then over here in the SO2 RGB, the dust is indicated with these blue colors behind the leading edge of the outflow boundary. We switch over to the radar from the Yuma site and note that the leading edge of the outflow boundary shows up very nicely here in the reflectivity, the velocity data, and then the correlation coefficient. By the time we get to the end of the loop, notice that we go from these low CC values indicating the signal with the blowing dust, and by the end of the loop you can see those pretty much go away. Now notice that we're moving away from the radar site, which is over here, so by the end of the loop the low CC values behind the outflow boundary go away primarily due to beam broadening with increased range from the radar site. Now, if we look further to the west and compare the radar data from Yuma here in the upper left panel with the San Diego radar, which is in the upper right panel, I also have the CC in the lower left panel, notice that San Diego doesn't really pick up on the dust signature like Yuma did. Remember that we still see pink colors in the dust RGB in that region.